Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon, very good day. Okay, so today we're going to continue with another topic from the chapter 3, which is method of analysis. Okay, previously we already done the nodal analysis for this chapter. Okay, now we're going to look into the mesh analysis. And then we're going to look into the difference between mesh and nodal analysis on how to solve the circuit problem using mesh and also nodal. Okay, so then we can see the difference between how to solve the electrical circuit problem using mesh and nodal analysis. Okay, so this is a kind of mesh that you will be faced. So this is the comparison between the nodal analysis and also mesh analysis. So basically nodal analysis and mesh analysis actually are the technique that we can use to analyze the electrical circuit. So basically for nodal analysis, it's based on the Kirchhoff current law, which is focusing more on the voltage at essential nodes in the circuit. That's why previously we're looking at the nodes voltage and also supernode. And then nodal analysis is effective for the circuit with mostly voltage source. So it's effective solution for the voltage source. So it involves writing the equation for current leaving and entering the node. And then so basically we use KCL, Kirchhoff current law, and then we solve the node voltage. While for the mesh analysis that we're going to look now, it's based on the Kirchhoff voltage law, KVL. So it's focusing more on the current flowing within the loop in the circuit, so meshing. And so we have to do the loop in the circuit, and then it's more convenient for the circuit with mostly a current source. And the mesh analysis is involved writing the equation for the voltage around the loop and solving for the current loop. So a key difference between the nodal and mesh analysis, while nodal analysis is deal with the node voltage, and then the mesh analysis will focus more on analysis with the current loop in the circuit. So nodal analysis is better suited with many voltage source, while for the mesh analysis is better for the circuit with numerous current source. So but both methods are valid for solving the circuit, but chosen method should be based on the circuit characteristic, kind of circuit characteristic, and the type of source that appear in the circuit, that have in the circuit. So basically so this is the one that I mentioned before. So nodal analysis is apply KCL to find the unknown voltage in the group circuit. Then we can use KCL, and then for the mesh voltage, mesh analysis, you apply the Kirchhoff voltage law to find the current. in terms of analysis, mesh is not quite as general as nodal analysis because it is only applicable to a circuit that is planar. A planar means it's not a cross circuit and it's not complicated circuit. Eh? So a mesh meaning that is a loop which does not contain any other loop within it. Okay, what is planar circuit? Planar circuit is one that can be drawn in a plane with no branches crossing another circuit. Otherwise, we can consider it as a non-planar. So a circuit may have a crossing branch and still be planar if it can be redrawn such that it has no crossing branch. So this is the example of a non-planar circuit. So we have, if we look here, we have the crossing element between another element. So this one we will not be able to, if we try to redraw, it still cross the other element. So we have to consider it as a non-planar. So it cannot be used in a mesh analysis. Okay. So this is another example. Okay, so this is another example. We have a circuit that also non-planar circuit because it's crossing and so this one will not be able to use in a mesh analysis. We have crossing branch here, and also this one. Okay. But we can try to redraw. Okay. So if we redraw, we will have like this, and this one, if you compare to previous circuit, we now have a non-planar circuit that can be redrawn. Yeah. Now we have no crossing branch, and this is planar circuit. We can consider it as a planar circuit. Okay, this is another one from non-planar circuit into a planar circuit. We can do the redraw for the circuit in order to have non-crossing branches within the circuit. So if we redraw back, we have like this, but it's quite complex circuit as well. But we can still do the analysis for this using a mesh analysis. Okay, the next one, a step to do the mesh analysis. So the first one, in order to proceed into the analysis using mesh method, we have to identify the mesh in the circuit. And then we have to assign a mesh current for each mesh. So that means how many loop current in the circuit. So we have to assign that for each of the mesh current, and then after that we have to apply Kirchhoff voltage law for each mesh, and then we have to use Ohm's law to express the voltage in terms of mesh current that we have. Okay, and then the third step is to solve the using a simultaneous equation. Basically, you can use calculator or you can use also the method that previously we learned in the class. Okay, so let's have a look into the example. Okay, so for this circuit, it asks you to find a branch current I1 and I2 in the circuit by using the mesh analysis. So we have, now we can draw the mesh current I1 and I2. Okay, so from this we have to trace, let's say for the I1 we can trace it. Okay, let's do this one. So let's say for the loop 1 we can proceed with minus 45 here. Okay, and then plus 2i1, and then plus 2i2 minus 2i plus 2i1, 12 to 12 12i1 minus 12i2. Okay, and then finally we'll see the 4 ohm resistor plus 4i1 again. So it, and this is all it will be equals to 0. Okay, so from this then we proceed with the second loop. Okay, okay, for the first loop we have to simplify first. If we do the simplification, we will have minus 45 plus how many in the I1, 2 plus 12 plus 4. Okay, so we have 14 plus 4, 18 I1, and then minus 12 I2, and then we can move this one, minus 45 into the other side. So actually we will have 18 I1 minus 12 I2 will be equals to um, will be equals to 45. Okay, okay, so this one, and then after that you can divide by 3, which is basically you will get 6i1 minus 4i2 equals to 15. So this one will be a first equation, yeah? And then we have to do the second loop. So for the second loop, um, we will have 12 i2 minus 12 I1, yeah? And then plus 9 I2, and then plus 30, okay, and then plus 3 I2, okay, 3 I2. So from this then we can simplify this to get 12 plus 9 plus 3 will be equals to 24 I2 plus 30 minus 12 I1, okay, equals to 0. And then plus 30 can be moved to the other side, or you can, or we can move I1 and I2 to the other side. So then we'll have 12 I1 minus 24 I2 equals to 0. And then from this we can divide by 2. We can divide by 2, or I think we can divide by 3 as well. Okay. Okay, now it divide by 6. So if we divide by 6, we will have minus 2i1 plus 4i2 equals to a negative 5. Okay? This one will be a second equation. Okay? Second equation. Okay, so from these two equations, you can use a simultaneous equation to get I1 and I2. Okay, so from these two equations, 6i1 minus 4i2 equals to 15. And for the first equation, and then for the second equation, we have negative 2i1 plus 4i2. This one will be equals to minus 5. So from this, you can use the calculator to get the equation uh, to get I1 value and I2 value. So I1 will get 2.5, Okay, then we let's try to do this question. Okay, so this is the second question. Find the output voltage VO in the circuit using mesh analysis. Okay, so for this, you um, can do the um, what we call it analysis. Okay? So you can do this analysis by using the mesh analysis using the current loop. So we will have a two loop. First loop here. This is the first loop, and then this one is the second loop, right? Okay. Okay. So then we know we got two loop. Okay. Right. So then from that we can use the three method for mesh analysis. The first one is to identify the mesh in the circuit, and then you have to assign the current. So we will have two current. One first loop current is in here, and then the second loop current. Okay, in order to find the output voltage. Right? Okay, and then the next one is you have to apply the Kirchhoff voltage law for each mesh and use Ohm's law to express the voltage in terms of the mesh circuit current. Okay, so for the first loop for I1 we will have 2k I1, okay, and then minus 30, and then plus 20 volt, okay, and then we have 5k I1 minus I2, right? So then when we simplify it, we will have like this. Uh, um, 7k I1 minus 5k I2, and then this will be equals to 10. So this is the first equation, right? So then we proceed to the second one for the second loop. Right, for the second loop we have 5k I2 minus I1, okay, and then minus 20 volt voltage source, and then we have 4k I2, okay, 4k I2. So when we simplify it, we will have minus 5k I1, and then plus 9k I2. That will be equals to 20 or 20, right? So this is the second loop, second equation. So from these two, I1 first loop and the second loop, we can do the simultaneous equation, or you can just use a calculator to solve to find the I1 and I2. Okay, so that's once we get the I2, then we can find the V out, V output, because V out will be equals to I2 times 4k, right? Okay. Okay, so then we get I1 and I2. So from the I2, actually we have 4k times I2. So this will be 20 volt. Okay. Alright, then we proceed with the next question. Okay? So for this question, you have to find the I1, I2, and I3. So basically, but you know that you have the first loop in here, first loop, and then you have second loop here. Okay, let's say IA and IB. Okay, because we have also I1, I2, I3. Okay. So for the first loop, we can just get our equation. Okay? So first start with the minus 12. Right, then we have IA 4K 4A, IA 4IA, okay, and then plus 6 IA minus IB. Okay, so then if we simplify it, we will have 5IA minus I3 3IB. This will be equal to 6. Okay, so this is the first equation. Okay, the second, what the second loop? IB. we have 6 IB minus IA plus with 10 volt, then plus with 2 IB. Okay? That will be equal to 0. Okay, so then from that we simplify the equation for the equation 2. So we have minus 6 IA plus 8 IB equals to minus 10. Okay? Okay, so then we simplify the equation again by divide by 2. Okay, we will have minus 3IA plus 4IB equals to minus 5. So the second equation. So from the first and second equation, we can find the value of IA and IB. I, so IA will be equals to 0.8182, and then IB will be equals to minus 0.6364 ampere. Okay, so from IA and IB, basically you can get the value of I3. For I1 is equals to minus IA and I1. For I2 is equals to IA minus IB, and for I3 is equals to IB. Okay, so you want to find each of this current, can just um, you can just use this equation. Okay, so once we get IA and IB, we can just get the relation between I1, I2, I3 to the IA and IB. So I1 will be equals to minus IA, which is minus 0.8182. Right? And then for the I2 is equals to IA minus IB. Okay? So this one we get 0.8182 minus negative 0.6364, so this will be equals to 1.4546 ampere, okay, for the I2, while for the I3 is equals to IB. So the answer is negative 0.6364 ampere. So done with that one, and then for the final example, so we look into the final example. For this, actually, if you look into the circuit, you can see that you have a three loop, I1, I2, and I3. And then the question asks you to find the I out, okay? IO. So IO is in here. So actually, uh, so this is the first loop, second loop, and the third loop. Okay, so let's find the equation for each of the loop. So for the first loop, you can see that it starts with a water supply minus 24, okay, plus with 10 I1 minus I2, plus with 12 I1 minus I3, and equals to 0. And then you can simplify the equation. You will get um, answer 11 I1 minus 5 I2 minus 6 I3 and equals to 12. And so this is the first equation. So then you can do the second loop. For the second loop is we have 10 minus 10 I2 minus I1 plus with 24 I2 plus with 4 I2 minus I3, that's equals to 0. So then from that you can simplify the equation to get 38 I2 minus 10 I1 minus 4 I3, and that equals to 0. So then you can rearrange back to make I1 first and then I2 and then I3. Okay? So then you can rearrange, you will get a negative 5 I1 plus 19 I2 and minus 2 I3, and that equals to 0. So this is the second equation. Then you can do the third loop now. So the For the third loop, we can start with a 12 ohm resistor. So 12 I3 minus I1 plus with a 4 I3 minus I2 plus with 4 IO, 4 I0, eh? 4 I0. So for that's equal to 0. Eh? And then actually you can see that I0 is equals to I1 minus I2. Okay, I1 minus I2 for the I0. So then we can rearrange, then we can arrange back our equation to be 16 I3 minus 12 I1 minus 4 I2 plus 4 I1 minus I2 equals 0. So then after that you can simplify this equation. You will have 16 I3 minus 12 I2 12 I1 minus 4 I2 plus 4 I1 minus 4 I2 equals 0. So finally you will have the final equation minus 8 I1 minus 8 I2 plus 16 I3 is equal to 0. Still you can simplify this by divide by 8. Okay, if you simplify this you will have minus I1 minus I2 plus 2 I3 equals to 0. So this is the third equation. So from first equation, second equation, and third equation, you can use a calculator or simultaneous equation to calculate the I1, I2, and I3. Okay, so now from this we can find that I1 is equals to 2.25, I2 is equals to 0.75, and finally I3 is equals to 1.5. Okay, so from this you can just find the IO value, IO, which is IO is equals to I1 minus I2. Okay, so I1 is 2.25 minus by 0.75. Okay, so you will have 1.5 ampere for the IO. Okay, so that's it for this example. Now we go into the next question. So this is the quiz. So you need to uh, uh, copy this question with a circle and on the paper, and then you have to write it down and write the answer. Okay, so you can refer the previous question to understand how it's been done. So you need to find the I1, I2, and V out and VO in the circuit using a mesh analysis. Okay, so using the circuit, find the I1, I2, and VO. Okay, then write on the paper the answer, and then you can scan or you can snap the picture, and then you have to upload into the portal. Okay? So I just create the what we call it the activity for your project, for your quiz. Okay, all right. So that's it for today. Thank you very much.